This is the Math 227 Statistics. Today, we will review the Chapter 1 and 2. Review Chapter 1 and 2. I'm going to talk about the question which are similar to the test question. We are going to have the test of Chapter 1 and 2. This is questions similar to the test question. First question, the scores on an exam from a class of 10 students are listed below. Those are the scores. They are not in ascending order. First of all, we are going to make an order in ascending order. How to make in ascending order? We can use stand-leaf plot. So we draw stand-leaf plot. What's stand-leaf plot? First of all, we draw stand. Stand. What is the stand? It's from the 10 digits. There's 10, 8, 7, 7, 6, 8, 9, 9, 9, 8. So smallest one is 6. So it is 6, 7, 8, 9, 10. And this is a stand. And then 1 digits is put on leaf. This side is leaf. So first number 100. So 100. Second number 85. So 85. Then next number 77. So 77. The next number 73. 73. Next number 68. On 6. Put 8. 68. Next number 88. 80s. So on 80s, put 88. The next number 95. On 90s, put 5. The next number 97. On 90s, put 7. The next number 94. On 90s, put 4. The number next 87. On 80s, put 7. This we call column, we call stand. And then to the right, we call leaf. So this we call stand leaf plot. And then arrange it in order. So then we put stand, still 6, 7, 8, 9, 10. And 8, 7, 3, put ascending order 3, 7. Then 5, 8, 7, put in order 5, 7, 8. 5, 7, 8. Next, 5, 7, 4, put in order 4, 5, 7. 4, 5, 7. Then next, 0. So this we call stand leaf plot. On the this one, question F, construct a stand leaf plot. And that is here. This is the answer. Then after we construct this standard plot, then we can put them in order. How to put them in order? First one, 68, first number. Next number, 73. Then next number, 77. Next number, 85. Then 87, 88, 94, 95, 97, then the last one, 100. Now this use standard plot, we can listing the number sorted in ascending order. So I put this order over here. This ordered. After ordered, now we can construct this table. This one, class limits already given. Those column, first column is given. 60s from 61 to 70 because the smallest one is 68, so we can have a 60s is one class. Then 70s from 71 to 80. Then from 81 to 90. Then from 91 to 100. This is given, question given. Now you are going to fill out those blank. First one, class boundaries. Class boundary is 61 minus 0.5 is 60.5. 70 add 0.5 is 70.5. And this is a class boundary because after rounding 5 or more than 5, round up, you got 61. Any number more than 60.5, you round up, and you will get 61 to 70.5, but not including upper boundary, not including upper bound, not including 70.5. So this is the class, any number between 60.5 to 70.5 after rounding will be the number, will be cover the numbers from 61 to 70 after rounding. Any number from 70.5 to 80.5 not include upper bound 80.5. After rounding, like 70.5 rounding is 71, and more than 70.5 up to 80.5 after rounding can cover all the numbers from 71 to 80. And so you do 81 minus 0.5, you got lower bound is 80.5. 90 add 0.5 is 90.5. And this will cover any number between 81 to 90. So that's class boundary. So 91 minus 0.5 got 90.5 up to 100.5. So those are class boundary. Next column, midpoint. Midpoint is 61 add 70. The two numbers add together divided by 2. 61 add 70 add together is 131. Divided by 2 is 65.5. 71 add 80 is 151. Divided by 2 get 75.5. 81 add 90 is 171. Divided by 2 is 85.5. 91 add 100. Add together divided by 2 is 95.5. So actually you find the first one is add together divided by 2. 61 add 70 add together is 131 divided by 2 is 65.5. Then every time you add by 10, get add by 10, 75.5, add by 10, 85.5, add by 10, 95.5. Now then figure out the frequency. From 61 to 70, you look at it's from 61 to 70, only one, only 68. So one number, put 1. From 71 to 80, which is 70s. So you have 73, 77. They are between 71 to 80. So it's 2. Frequency is 2. From 81 to 90, 80s. So 85, 87, 88. So 3. 3 number. So frequency is 3. 91 to 100. So this is 90s. So you have a 94, 95, 97, and 100. So has 1, 2, 3, 4. Have 4 numbers. Put 4. Now those are frequency. Then relative frequency. Relative frequency is a frequency f. This is f frequency divided by total number n. N is a total number. N is what? N is 10. Here has total 10 numbers. So it's 1 divided by 10. 1 divided by 10, you can times 10 both sides and put the percent as 10%. 2 divided by 10 times 10 on numerator and denominator, got 20%. 3 divided by 10 is times 10 both sides, got 30%. 4 over 10 times 10 both sides on numerator, denominator, got 40%. So this we also call percentage frequency, relative frequency. This 1 over 10 is 2 over 10, 3 over 10, 4 over 10. We call relative frequency. And convert to percentage. It's a percentage frequency. And they are equal. Cumulative frequency. Cumulative frequency is from 61 to 70 has 1, 1. So first one is the same as is 1. Cumulated is accumulated. So from 61 to 80 is from 61 to 80 is 1 add 2. Is 3 frequency, 3 number. 61 to 80 has those 3 number. 68, 73, 77 has a 3 number. 3 scores. And then cumulated. So it's from 61 to 90. So is the 3 add together. So it's 3 add 3 more, get 6. 3 add 3, get 6. Or you do the 3 add to 1 add 2 add 3 also. Add together is the score from 61 to 80 to 90. So like 1, 2, 3, 4, 5, 6. Those 6 scores is between 61 to 90. Then the last one, from cumulated from 61 to 100. So it's 6 add 4. Total is 10. This is the score from 61 to 100. So it's actually 1 copy to the right, then 1 add 2 is 3. 3 add 3 is 6. 6 add 4, get 10. Then next, construct the frequency histogram. So construct the following visualizations of the data using grouped frequency distribution. So this we call grouped frequency distribution. So we will use the boundary. When we draw frequency histogram, use class boundary. So the horizontal line use the class boundary. And since here started at 0 and we use this zip, that means that the number we cannot show up. So we start at 60.5. First boundary from 60.5 to 70.5. So from started over here 60.5 to 70.5. Then from 70.5 to 80.5. And those the lengths should be equal lengths. Add 10, 70.5, add 10, 80.5, add 10, 90.5, add 10, 100.5, add 10, 110.5. So those lengths should be equal lengths. Then this side we call scores. Give the name is the scores. And the vertical line and mark 1, 2, 3, 4, 5. Also equal lengths. Use the ruler. Equal lengths. And indicate frequency. Vertical axis is a frequency. Horizontal axis are scores. Then first frequency is 1. So at 1 and draw this horizontal line and draw this vertical. And the second one is 2. So at 2 and draw a horizontal and then draw vertical. Then from 80.5 to 90.5 is frequency is 3. So it's at 3 and draw this. Then from 90.5 to 100.5 is 4. So at 4 draw this. So you have to be like this. Use ruler. This is a 4 and draw this. And that's a 3. You draw this. And this is 2. And that's 1. And then you draw this verticals. And this we call frequency. Histogram. Use boundary. Then next one is relative frequency histogram. I forgot one thing. And you have to indicate the title of this graph. The title of this graph is a scores on an exam. Then next one, this relative frequency histogram is also use class boundary. For horizontal axis, you started at 0 and those zip. Then started at 60.5 and use the ruler. Then measure equal lengths. And mark 60 start at 60.5, add 10, 70.5, add 10, 80.5, add 10, 90.5, add 10, 100.5. So those lengths should be equal. On vertical, indicate 1, 2, 3, 4, 5. But this time is 1 out of 10, 2 out of 10, 3 over 10, 4 over 10, 5 over 10, because we are going to use relative frequency. Relative frequency is frequency over the total n, and here has a 10, n equal 10. And then on vertical, you have to indicate, we call relative frequency. On vertical is a relative frequency. Then between 60.5, from 60.5 you draw a vertical line, and the 70.5 you draw a vertical line. between 60.5 to 70.5, relative frequency is 1 out of 10. So at this, and you draw a horizontal. Then from 70.5, you draw vertical. From 80.5, draw vertical. Then from 70.5 to 80.5 is 2 out of 10. So on 2 out of 10, you draw a horizontal. Then from 80.5 to 90.5, and you draw this vertical. Then it's 3 out of 10. So draw a horizontal. Then from 90.5 to 100.5, you draw this vertical is a 4 out of 10 and draw horizontal. And you can see actually they are the same shape. Just the only difference is this one is a frequency. You are indicate 1, 2, 3, 4, 5. And this for this is a relative frequency. You have to indicate 1 out of 10, 2 over 10, 3 over 10, 4 over 10, 5 over 10. So also use boundary, and you have to write down horizontal is 4 scores. And the title of this graph is scores on an exam. The next one is pie graph. Pie graph, because pie graph, we have to draw a pie. We have to indicate class limit. So I copy this class minute limits from 61 to 70, from 71 to 80, from 81 to 90, from 91 to 100. We are going to use relative frequency, percent. So we already, I copy this relative frequency, 10%, 20%, 30%, 40% over here, 10%, 20%, 30%, 40%. Because on the pie graph, we have to indicate class, and we have to write down how much percent relative percentage frequency. Also is a relative frequency. Then we have to figure out the angle of each piece. Angle is equal relative frequency times 360 degree. So like this one is 10%, which is 1 out of 10. 10% is 1 out of 10 times 360 degree. So this is 1 out of 10 times 360 degree, and 0 cancel. You got 36 degree. And this one is 2 out of 10, 2%, 20%. So this one is 2 out of 10 times 360 degree, cancel. 2 times 36 is 72 degrees. And this one is 30%, is 3 out of 10. So this is a frequency over the total n times 360 degrees. Cancel. 3 times 36 is 108 degrees. And this is a 4 out of 10. And that is a frequency over n times 360 degree. Cancel. 4 times 36 is 144 degrees. So it's F over n times 360 degree. It's the angle, degree of the angle. Now we are going to draw how to draw this pie graph. First of all, we draw a circle, and you can use compass or use any object which is a circle object. Then you can draw a circle. And then here has a center of the circle. On center of the circle, and you draw a line, use the ruler, and use protractor protractor. And this put on the center of the circle, and this line started with 0 degrees, 0 degree, and this line line up is 0 degree. And first class is 36 degrees, so go 10, 20, 30, 35, and one more, 36. Then connect. Then you indicate this one is from class is 61 to 70. Relative frequency is 10%. 1 out of 10, 10% here. 10%. Second one is second class is 72 degree. 72 degree. So you are going to put this center, line up the line with 0 degree. So start at 0 degree. Center, started line, 0 degrees on the line. 72 degree. 10, 20, 30, 40, 50, 60, 70. Here 70. 2 more, 72 degrees. And connect. And indicate class, 71 to 80 class. And it's 20%. The next class, this also center, line up the line is started at 0. This is 0. Next class is 108 degree. So it's started at 0, 10, 20, 30, 50, 90 until 108. 105, 106, 107, 108 here. Then connect with center. This class 71 to 80. It's 30%. Then remaining 81. Okay. It should be 81 to 90. 71 to 80 is here. So this is 81 to 90. Then this 91 to 100. And it's 40%. So this finished the pie. On the pie graph, you have to use pie graph. You will use class limits and put on the pie, put the class limits, and use relative frequency, 10%, 20%, 30%, 40%, and use the protractor, measure the degree of angle, and you don't need to write the degree of the angle. You only indicate class limits and how much percent. Don't write the degree, how many degree of the angle. The next, what is the degree of the angle of the piece on the pie graph representing the 91 to 100 class? And this angle, that's the 144 degrees. Is this one, 144 degrees. This is for this angle. The next, stand lift plots. That's we already do it in the beginning of this lecture. In the beginning, we do this standard plot. First of all, put the stand from 6, 7, 8, 9, 10, and then put those leaves, and then put those in order, ascending order. That's standard plots. G. What is the range? Range is equal to the maximum minus minimum. So for those numbers, maximum is 100. Minimum is 68. Subtraction 32 is the range. The next we will talk about the first chapter. First question, second question, you want to survey the living conditions in a 3-story apartment building that has a total of 80 units. Determine whether the following samples would be considered a random sample or stratified sample or systematic sample or cluster sample. A. Choose 5 random units from each floor of the building. Now here has 3 floors. First floor, you choose 5 units. And the second floor, you choose 5 units. Third floor, you choose 5 units. So this building has 3 floors. Each floors randomly choose some of them. That's what we call stratified. Stratified is the entire population is a 3-story apartment partitioned into subgroups. Now here is 3 floors. Each group is 1 floor. And then randomly selected partial of them and form a sample. That's what we call stratified. It's the entire population partitioned into subgroups and randomly selected the elements from every subgroup. That's stratified. Second one, only select the first floor of the apartment building. That's cluster. What is a cluster? It's a population, the whole population. This population you subdivided into subgroups. And you only selected one entire subgroup or 2 entire subgroups. You have to select like this. Have 3 buildings, 3 floors. You select the first floor, entire first floor, form a sample we call cluster. Next, draw 20 cards randomly from a bucket of cards labeled 1 through 30. Randomly. From the 90 cards, there are 90 cards. Then you will draw 20 cards from 90 cards randomly. The numbers drawn corresponds to the unit number selected for the sample. So there are 90 cards. You randomly select 20 cards. This is random sampling. the next. Starting from 1, choose every fourth number until 90 is reached. The corresponding units for these numbers would be the sample. So every fourth number, that is systematic sampling. That is we learn chapter 1, we have this examples. Random sample like this computer generated telephone numbers is randomly, that's random sample. Systematics is every third being selected is systematic sampling. The next stratified sampling is population divided into subgroups like this, men and women, 2 subgroups, and randomly selected partial from each subgroup, from every subgroup, randomly selected equal amount of elements. And that's we call stratified. Cluster sampling is entire population divided into like this, divided total 32 subgroups, and the selected entire subgroup, sum of, like here, select 3 entire subgroups. So cluster is selected entire subgroups. Stratify is every subgroups you need to select certain amount of elements, equal amount of elements from every subgroup. Cluster, you don't select every subgroup, just select entire subgroups. The next one is for the following variable, determine the level of measurement. Nominal, if you use the name, n is nominal. Ordinal is have order, is the name but with order. Interval is a number but no starting 0. Ratio is a number have a starting 0. So like A, major fields of studies. That's the name. For example, major field is chemistry, major field is math, major field is English. There's no rank of those names, so it's a nominal. Pizza size, like small, medium, large, those in name, but have a rank, have order. Small is less than medium, medium is less than large. That's what we call ordinal. Salary of an employee start at 0. The minimum salary is 0, have a starting point. There's impossible negative salary. So it's starting at 0. So have the starting zeros we call ratio. Next, temperature, a measure of heat. The heat can be negative temperature, like a negative 1 degree Fahrenheit, or 0 degree, or positive degree. So there's no starting 0. You can below 0. That is what we call interval. So ratio, interval are numbers. Ratio have a starting 0. Interval, no starting 0. Number and the ordinal are character or letter. Nominal is the name, no rank. Ordinal is the letter or words or name, but with order, with rank. Then next one, For the following variable, determine whether the variable is discrete or continuous, and write A, the speed of car. The speed of car is continuous. Continuous is a real number or decimal number or fractions, and between two numbers have infinite real numbers. Then the speed is continuous. The time to travel for a trip also continuous, because between two real numbers still have a real number. That's continuous. Number of the people in a conference is discrete, because people, you have one person, two or three or four. Is impossible, you can use 1.5 people and 2.5 people. Only you can use counting number, can be counted as a discrete number. The money of purchase a computer also discrete. You can purchase of computer by $1,000.099, and then or you can purchase by 1,000.98, because we stop at a cent. So between the two, there's no more amount of money. Between 99 cents and 98 cents, there's no more amount of money, because we stop at cents. So that's discrete. Discrete is between two numbers, has no more numbers. That's discrete. Continuous is between two numbers and still have numbers. Is continuous. The next, based on the amount of car insurance he paid to last year, according last year he paid. So the John expects he will be paying $1,000 this year. So from past experience, then you determine, you get prediction of the future from past experience. You can predict your future, and this we call inferential statistics. Inferential statistics is according the past data, then you predict the future. And what is the descriptive statistics? Descriptive statistics, you don't base on the past data. So here say this example is descriptive statistics. No, answer is false. This is inferential. There's two kinds of statistics. One is inferential, one is descriptive. So this is according past data, and you go to predict the future, and we call inferential statistics.